Okay, so today we're going to talk about constructing objects. Your assignment, I just posted it, will be, as the name suggests, create a program that creates 3 objects: a car, including the make, model, color, and door count; a driver, including name, sex, age, and eye color; and a passenger, including name, sex, age, and shoe size. So it doesn't have to be you. I don't care. You can just make these people up. But I want 3 separate objects, all initialized, so that you can print them. So I essentially want you to print them. As maybe I should have fixed that as well. Well, it doesn't matter. I already put it up there. I'm not going to change it. I'm lazy. So let's talk about objects. So last time we talked about classes. Classes are essentially a container for objects, more or less. We'll use some liberal terms. So last time we just created classes. So let's start with that. So class person. I'm just going to use tab today because I don't want to have to go back and redo everything because there's a lot of lines. So today we're going to define, initialize, I'm going to say self, name, and age. Yes, 2 underscores for the init. Okay. So we'll say player1 equals okay. So what have we done?
Created a player, a man. His name is John. He's 36 years old.
Same thing. We've created within class. We've initiated a object, or essentially that's a constructor. We've constructed an object that has self, and that can be anything. It doesn't have to be self. But we're just going to call it self. That's kind of how it's referred to. That's the self field. They're going to have a name and an age. And then P1 we've initialized class. So P1 is equal to a object, a person whose name is John, and he is 36 years of age. So let's go ahead and run it. See what we get. There we go. So we got John 36. Not as good as Austin 3. What is it? Austin 316. What? Anyway. So the only real difference than last time is that we added that initialization. It doesn't seem like it does anything, but whenever you get later on in programming, you have to do that if you're going to use object-oriented programming in Python, which you may not. You may never use object-oriented programming. You may just go through Python. If you guys someone becomes a programmer, you may go through your entire life just scripting, and that's fine. But this is for games. This is for you can make customers, objects. You can make anything an object. It's just if you want to carry something that has attributes, that's essentially what it is. So if you ever want to make a game, you'll have to use objects. So you don't have to. I mean, you can make a text-based game solely that's just, decision-based. But if you're going to make a 2D or 3D game, you have to have an object. Or 2, or 3, or 1,000, however many you got. So let's build on this. Let's say we want to add another function here. We want to define we'll just call this my function for now. Nothing fancy. We're going to use self. What does that mean? Using self as the item in this function, what is that going to do? Anybody? Bueller? Bueller? Well, let's find out. Let's see what it does. Do we want to use a plus here or a comma?
I think comma,
Why?
because you're needing to have something on after the quote.
Plus can do that too. Why would plus not work here? Well, look at the difference between John and the number 36.
Okay, so it's dividing words and numbers.
So if we want to add an integer, what happens whenever you add an integer? It tries to mathematically add it, right?
It has to do math, yeah.
Right. So we want to do a comma.
So you're saying those first two will add to each other?
Whenever it's string, it's concatenate. String plus string just adds. This puts the strings. Hello, my name is plus string is hello, my name is John. But if it was an integer, it's going to try to add them. So.
So basically, we're just defining self from the init above.
Yes, whatever you just said. Okay. So instead of doing, well, let's go ahead and just add on to this. So now we're going to call whoops. No one saw that. So what do you think? What do you suppose this is going to do? No wrong answers. What do you suppose this is going to do?
To make it a function. Does it recall?
It's just gonna say the name of
Yeah.
the person.
How does it do that?
Function.
Because you call,
Yeah, you call it function. Self. Oh.
you're using self from this. Essentially, you're calling this object to fill in these attributes. So this self.name is an attribute of this object. So make sure I didn't make any mistakes. There you go. Well, aside from not putting a space.
Putting a space in between the comma and quotation.
There we go.
I got a question.
Hello, my name is John, and I'm 36 years old. There's actually an extra space in there too that bothers me.
Mine's giving me a invalid
Say it's 13.
space.
What's that?
I'm getting this invalid syntax. But I don't know why I said that.
You indented wrong.
Right here.
Yes. You probably need the backspace. Backspace.
That's right.
Also, you're missing a colon. So what?
I said unexpected.
What's that?
I said unexpected.
You still did?
Yeah.
Even though you put a colon at the end of the defined statement.
It's saying that person function has no takes like arguments. What am I doing for this statement?
I don't know. You should look at my program and then compare yours and figure it out yourself. Because you'll learn what you did wrong. So, So what? So what? We just did that. What does all that mean? Well, essentially, we wrote a function that calls your object. So, you know, if this was the start of a game, you know, set player health 100, you know, and this introduces your character. This is, you know, hello, my name is John, and I am your character. I am 36 years old, or I have 36 hit points. Please don't get me killed, senpai. This is just the early stages of some greater things you guys can do in Python. Does everyone understand what's going on, though? I'm sure some of you are thinking this is dumb. Why am I learning this? But who does not understand what's happening here? So anytime you make an object, it gets stored in memory, so that later on in the program you can call from it. It knows where it's written to memory, and it can pull from that. And as your program's running, you can change the attributes. You know, your guy's walking forward and he hits some spikes, he loses some health. Rather than having to hard change some numbers, it just affects what's in memory. It changes 36 to 15. It was a big spike. You really skewered yourself. So while this is running, thus your character is alive in memory, or it's doing something. That makes sense? Like I said, does anybody not understand what's going on? It's pretty simple right now. Okay. And this is more or less your assignment. So pretty easy, shouldn't be too hard. I could have made it a little more difficult and say, once you've created all your, once you've created your people, put them inside, and then you'd have to create a container within your car that the driver and the passenger is in. But maybe next semester. Then you can kind of see how things can interact. Okay. Let's try something a little more difficult. So let's do class rectangle. So what have we done here?
Created a box or rectangle.
We created an object that is essentially a rectangle. Well, we're calling it a rectangle. Right now it's nothing. But we're creating a rectangle that has length, breadth, and unit cost. So what kind of rectangle is this if it has breadth? And you guys know what breadth is?
Width.
More or less.
Yeah.
So this would be referring to like a unit of land. Okay. So we're going to define.
What is that, your plane? What would be like your plane? Or
It's like your acreage of land. What's that do?
Defines the size of it, you get
The perimeter. What's perimeter of it? What's the perimeter of a rectangle? You guys remember?
Length and width.
2 times length, 2 times length plus width.
It's just the outside measurement.
You mean you have the underscore per unit cost?
Yes. Okay. Everyone understand what's going on? Since they were just making functions to do the calculations for us. So if we need to, as we're doing, our calculations for how much to charge the person for their acreage of land, we can just call whatever function we need rather than just having to hand jam it in there. So let's create a rectangle. Space this out a little for you guys. So we've essentially created a plot of land that has 160 length, 120 breadth, and is $2,000 per whatever, per unit. We'll say this is in feet. So let's go ahead and do something with this. Okay. You guys remember your formatting stuff? It's been a long time since we talked about it. Essentially, this is just going to put that calculation right there for us. Assuming this works. Hopefully I didn't make any mistakes in my dictation from what I did. There we go. So this is in centimeters. So it's 19,200 centimeters squared in area And the cost of the field is a lot. We'll say those are in pesos, so $38,000, $38,400. Because you just dropped 30 zeros and calculating over pesos. So what's happening here? What's happening here? As my 34-year-old man voice cracks. I haven't decided if I'm getting sick or not. I think I might be, but can't tell. So what's happening? If you don't know the answer, you can ask a question. This is very basic object stuff. So if you don't get it, you should ask questions so you can understand it if you ever do have to do object-oriented Python programming, which you probably won't, but Java's kind of the object. They took object-oriented programming and cranked it to 11.
What exactly is the %SCM2?
So %S is just looking for your formatting. So this essentially calls this, and then centimeter squared is just your unit of measurement.
Oh. Yeah. I think it's CM2 by 3 off a little more.
Questions? Any other questions? That was a good question. All right, pack up. Let's go home. You guys got nothing else? Surely someone has a question. Someone is not getting this and is being shy. You don't have to be shy. Or maybe you are all getting it. I don't know. You might be asking, why would you do it this way? So, we're at right here,
26.
because you're calling the object, or you're calling the class rectangle. You're assigning the object rectangle length, breadth, and unit cost. So
It's using all that little rectangle.
yeah. So this stuff right here is getting plugged in right here.
And then it's just calling rectangle 1 as the name of that particular rectangle,
Yeah.
right?
So this object rectangle 1 uses this class. Essentially, your actual object is this rectangle 1. Rectangle 1 has these attributes in class rectangle.
So the first one's length, the second one's breadth,
Mhm.
and 2000 the unit cost, right? Okay. So I was thinking self would be 160, but it's calling self.
Yeah.
As itself.
And whenever you're doing classes and objects using the init, self is essentially just something that's used on the inside. You can call this anything. You can call this Bananarama 747, but you'd have to type that in Bananarama 747.length. So itself is just what most people do. So essentially, what you're saying is self length equals length. So this class object is using self. So rectangle 1, its self.length is equal to 160, self.breadth is equal to 120, self.unit cost is 2000. So it's kind of just an internal definer that you have to have something there. So if I would have just not put that there, it would have flipped out. It would not have worked. Unless you did length.length, in which case you wouldn't have length. So you'd have to have length.breadth equals it. It'd just be stupid. It would make no sense to anyone, and it wouldn't work like you wanted it to. So that's why people use self. It's just easy to spot and understand what you're doing. So less for yourself, more for other people.
So the purpose of defining classes is basically saying this is the class, so that I can call it later without having to retype all this other junk.
So if you had, and you can use, and you could do stuff. You get user input for all this. Like, what do you want to call it? This is my rectangle 1, and then you put in the parameters. And then later on, if you wanted to call, like, you know, someone wants to buy rectangle 1, rectangle 3, and rectangle 6, you would still have those. Those would still exist in memory within your program. So imagine a program that you have all these plots of land and people are coming in and buying them, and you want to do all the calculations. So you say, okay, which one do you want to buy? Rectangle 1, okay. Well, rectangle 1 is 160, 120, and it's 2,000 per unit. And then you put that in as a total. And then later on, if you wanted to add them, you could just say rectangle 1, call the calculate cost. So you could do rectangle 1 dot calculate cost plus rectangle 3 calculate cost. And then you could add that together and give your customer a total of what it would cost to buy all of them, rather than having to. And then then you could go further and say, you know, once those are paid for, you could say, you know, remove from list, so that rectangle 1 is no longer accessible. You've put it into another. You could put it into a list of stuff that's no longer there. So if you try to call it later, it's essentially untouchable. So you guys kind of see how this could become like a accounting program for a land seller. That's the reason you use objects. Because it'd take a lot more coding to do all that if you couldn't just call the object later. Because essentially all that stuff all that stuff could be added in to another part of the program, and then you can just say you want rectangle 1 and rectangle 2. Okay, well they're this big. The area of those two are this big, and they'll cost this much money. So rather than hand jamming, granted you could just write it on a piece of paper, but you could have this connected to a SQL database, and as soon as that gets bought, you change the available flag from true to false, and then if someone else on the other side of the company tries to pull it up, they'll notice, oh, it's, you know, of course you'd have to pull available true false, but we're not going to talk about pulling from SQL databases. That's well beyond the scope of this class. But I just wanted you guys to kind of see, like, this is kind of the basic idea of an actual program that's useful, other than just saying hello world, because that's pretty impractical, right? I mean, what are you going to do with that? Show your friend that you know how to type print hello world? I mean, it's pretty pointless, but at least now that you guys have achieved like nirvana of programming, right? So this is just a kiss into what actual programming looks like. Either to scare the ones who think they're going to be programmers but don't have the cojones to do it. And as I said, programming is hard. It's a very hard discipline to get into if you don't have the right mind for it. If you enjoy words that don't mean anything to anybody else but to you, they're everything, and you can look at this and go line by line and say this is what it does, then maybe programming's for you. And you can make a lot of money doing it, because most people don't. Most people hate programming. As I've taught this class, 1, 2, 3, 4, 5. This is my 5th or 6th time teaching this class. There are people that just don't get it. They will never get it. And that's fine. It's not for everybody. But there are people who truly do get it and find it very interesting, fun, exciting, and easy. So, but at least now you can kind of see what a real program might become. And the true programmers in here are thinking, how can I make this useful to myself or to others? You're thinking, well, I can add this. How would I add that? Well, I can just do that. If you have that kind of brain, then you're probably going to be a pretty good programmer. How many people are actually interested in programming in this class? So, if it's here or there, then you shouldn't do programming.
Yeah, well, I'm like doing it towards like networking hardware.
And here's a good life lesson for all of you. Mr. Clifton over here can verify this. If you ever feel ambivalent about something, like I kind of like programming, I might, maybe I'll do that. Don't do it. Don't do that with anything. If you're marrying some dude or some chick and you're like, if you have any doubt, if it's essentially look at your life and the things you want to do, make a 0 to 10 scale and say, programming, that's like a 6, maybe an 8. I'll put it an 8. Networking, 4. Anything that's below a 10, throw it out and don't do it because you're not going to be happy probably. Anything you put as a 10, that's what you should pursue. If you feel ambivalent about something, it might get better. Maybe when you get into a programming job, you're like, yeah, I did it. This is the right decision. But most often than not, you're going to go, Jesus Christ, what have I done? So, some life lessons. It's either a 10 or a 0. Or in programming, 0 or 1. Either you're going to do it or you're not going to do it. So, questions, comments, concerns, complaints, sling upon me your arrows of malcontent and anger and aggression and self-doubt, and I'll do my best to help you with it. Okay, I'm going to turn off the recording. Click. Okay. Any real questions? I didn't turn it off. I joked. I tricked you. I pulled a sneaky one. What's up?
Oh, I just need to check something.
I mean, it's all right there.
I know, but I'm just more
Okay.
better eyes. Okay,
Yeah,
I'm just
great.
trying to see my.
All right.